Hello class, today we are going to continue on this foldable, but today we're going to talk about functions. So make sure you're on your relations foldable with all of your information from the last video filled out, and we're going to add onto these notes. So functions are defined as relations in which each member of the domain is paired with one and only one member of the range. So if you remember, we defined the domain as all the x values, and the range is all the y values. So using this definition, it says each member of the domain, so every value you put in for x, is paired with one and only one member of the range. So every x value has exactly one y value. In easier terms, x cannot repeat. If you have 1 for x, you're only going to see it one time. You're not going to have 1 and then a bunch of different y values. So this is super important because you'll have a lot of relations, and relations can do whatever they want. They can have as many different pairings as possible, but functions specifically have one pairing. So we're going to go through each of these examples, and we're going to label them as functions or non-functions. So if you look at the first box, we have our ordered pairs. Remember the definition, x cannot repeat. So look at your x values. Remember, x comes first. So we have -4, -2, -1, 1, -2. Right off the bat, you should realize that -2 repeats. It says -2, 3, and then -2, 8. So this is not a function. Why? Because x cannot repeat. Super simple. But if we look at the bottom, we have -2, 1, 0, 1, 2. Perfect. All different x's, and each of them have one y value. So this is a function. Top one not a function. The one on the bottom is a function. Okay, let's look at this table. Here we have -7, 0, 3, 7. Now notice something, and this is really important. All the x values are different, right? So this is a function. But if you look at the y values, you might say, oh, there's 3, 0, 3, 0. The 3's and the 0's repeat. But that is okay. They can repeat. What we're looking for is the x value. So because the x values are all different, this is a function. Now when we look at this bottom graph, real quick, you can just see there are two 1 values. It says 1 is 3, and then if you put in 1, you get 5. So we know that this is not a function. Okay, I hope you're catching on to this. It should be really easy. You're looking at the x values. Do they repeat or do they not? Now, let's look at these graphs. Because the numbers aren't just listed out for us as x, y, x, y, you might think it's a little more challenging to find whether or not this is a function. But really, there's something that can help you very quickly. It's called the vertical line test. Now, what is a vertical line? I hope you know it's a line that goes up and down. So what this says is that if a vertical line drawn anywhere on the graph passes through more than one point, it is not a function. So, if you draw a vertical line anywhere on the graph and it passes through more than one point, it is not a function. And here's why. If you look at this graph, you can see where the points are. So if I drew a vertical line here, we'd be fine. There's just 1 point, 1 there, just 1 point, 1, 1. But if you notice right here at where we have 4, if you draw a vertical line, there's 2 points that hit it. So according to the vertical line test, this graph is not a function. And if you think about our definition of a function, it says x cannot repeat. The reason this works is because, remember, the x value is always the value you go first, left or right. So the x value is repeating right here. This point would be 4, 3, and this point would be 4, negative 2. So we have a repetition of the x value. So not a function. So use the vertical line test when you're on graphs. You don't have to list all the ordered pairs or anything. But if you can prove that no vertical line passes through more than one point, then you're safe. So on this bottom one, you'll see that, okay, this vertical line's fine, this one's fine, it's all fine. This is a function. Because each vertical line only would have one point on it. The x's don't repeat. Alright, now flip over to your mappings. Remember, we put all our ordered pairs in here. So you could do this one of two ways. Now you could list all the ordered pairs and look, okay, do the x's repeat. But if it's given you a mapping and doesn't tell you you have to list out the ordered pairs, that's kind of some extra work. So just look at each arrow. For this one, each x value points to exactly one y value. Right? So 6 goes to 1, negative 6 goes to 1, 9 goes to 11, so on and so forth. This, you can tell pretty quickly, is a function. Now when you look over here, remember, these are the x values and these are the y values. If you look at 4, remember, it's pointing to two different places. So this x is repeating. So if the arrow is ever going from one number in the left bubble to more than one number in the right bubble, this is not a function. Because our x repeats twice right here. Now, it doesn't necessarily matter that 4 and 2 are both pointing to 10. They can have that. Remember when we said your y values can repeat. That's not a problem. It's when we're looking at our x values. So because of this 4, this mapping is not a function. So I hope that's pretty clear. If you know exactly where the x values are in every representation, you should be able to determine pretty quickly whether or not each thing is a function. So before you come to Math Workshop, I have a quick practice problem for you. Again, it's not written on your notes, so you may need to pause this video. You don't have to copy the questions down, but write your answers down either somewhere on your foldable or in your notebook. I have two things. One's a graph, one's a mapping. It says label each of these as a function or not a function. So I know this graph's not labeled perfectly or anything, but just looking at this graph, tell me function or not and why, and looking at this mapping, function or not and why.